Hey everyone, welcome to the channel. In today's video, we're going to talk about something super important if you're just starting out programming: logic formulation. This is part of the fundamentals of programming, and trust me, once you understand this, everything else in coding gets way easier. We'll cover what a computer program actually is, the programming cycle, how algorithms work, and even how to write a pseudocode. Don't worry, if those words sound scary right now, by the end of this video, you'll understand them in the simplest way possible. Before we start, a quick tip. If you're new to programming, don't rush to memorize everything. Focus on understanding the logic first. Coding languages may look different, but the logic behind them is always the same. Once you get that, switching between languages becomes way easier. Alright, first things first. What exactly is a computer program? A computer program is basically a set of instructions you give to the computer. Think of it like a recipe in a cookbook. If you want to bake a cake, the recipe tells you, Step 1, get the ingredients, Step 2, mix them together, and Step 3, bake in the oven. A computer program works the same way. Instead of flour and sugar, you have data. Instead of baking, you have calculations or process. And in the end, you get the result, just like you get a cake. So in short, a program is just instructions written in a way that the computer can understand and follow. Now that we know what a program is, let's talk about the process of creating one. This process is called the programming cycle. There are 4 main steps. Problem definition is figuring out what you need. Problem analysis is breaking down the details. Algorithm development is planning the steps. And coding and debugging is actually writing the code and fixing the mistakes. Think of it like building a house. First, you need to know what kind of house you want. Then, you analyze what materials and budget you need. After that, you make a blueprint. Then finally, you build it and fix problem if something goes wrong. Step 1 is problem definition. This is where you clearly identify the problem. Let's say your teacher asks you to create a program that tells if a student passes or fails based on their grade. The problem definition here is the program should accept a student's grade and output if they fail or pass. If you don't clearly define the problem, you'll end up coding the wrong thing. So this step is all about asking, what exactly do I want my program to do? Step 2 is problem analysis. Now that we know the problem, we need to break it down. In problem analysis, we ask 3 questions. What are the outputs? The data we give to the program. What is the process? What the program does with the data. And what are the outputs? The results we want. For our grade example, the input is the student's grade. The process is check if the grade is greater than or equal to 60. Output is print pass if yes, otherwise print fail. This step is like looking at the ingredients of a recipe. What do we have? What do we do with it? And what do we want at the end? Step 3 is algorithm development. An algorithm is just a step-by-step way of solving a problem. For example, if you want to make a cup of coffee, your algorithm might look like this. Boil water, add coffee powder to a cup, pour the hot water, and stir and drink. That's an algorithm. It's clear, it's step-by-step, and it has a result. You get coffee. In programming, an algorithm works the same way. It tells us the sequence of steps we need to solve the problem. But not just anything can be called an algorithm. A good algorithm has three important characteristics. Each step must be specific and clear, no guessing. It must have a finite numbers of steps, meaning it eventually ends. And it must produce an output, otherwise it's useless. So if your algorithm says keep adding one forever, that's not valid because it never ends. Or if your steps are too vague, like make something happen, that's also not valid. So good algorithms are like good instructions, clear, short, and it leads to a result. Once you have your algorithm, step 4 is coding and debugging. This is where you actually translate the algorithm into programming language like Python, Java, or C++. But here's the thing, coding isn't perfect the first time. You'll make mistakes. That's where debugging comes in. Debugging is just the process of finding and fixing those mistakes. For example, if you write a program to add two numbers but it gives the wrong answer, you go back, check the code, and fix it. So debugging is basically proofreading your code. Debugging can sound intimidating, but it's actually a normal part of programming. Every coder, even professionals, spends a lot of time debugging. Think of it like testing your recipe. Maybe you added too much salt or forgot an ingredient. So you taste, fix, and improve. When debugging, the computer often gives you hint through error messages. Instead of panicking, read them carefully. They're basically the computer of saying, hey, something's off in line 3. Now, before we even write real code, there's a super helpful tool called pseudocode. Pseudocode looks like a code, but it's not really a code. You can't run it on computer, but it helps you think like a programmer. Think of pseudocode as a rough notes. If real code is like writing a novel, pseudocode is your outline or draft. It's written in plain English, but structured like a code. Here's an example. This looks like a code, but it's not tied to any programming language. Whether you use Python, Java, or C++, you can translate this pseudocode into that language. That's why pseudocode is super useful. It's language independent. So how do we actually solve problems as programmers? First, write a general algorithm. Don't worry about coding yet. Refine it, making the steps more detailed and closer to real code. And then, write pseudocode to organize your thoughts. This saves you so much time instead of jumping straight into coding and getting stuck. You plan everything first, then translate it into actual code. Alright, let's quickly review everything we've covered today. A program is just a set of instructions, like a recipe. The programming cycle has 4 steps. Define the problem, analyze it, create an algorithm, and then code and debug. Algorithms are step-by-step solutions that must be clear, finite, and give an output. Pseudocode is like a draft version of your code that helps you think in a structured way before coding. If you can master these basics, coding becomes way less intimidating. Remember, programming isn't just about code, it's about thinking logically. Once you break down problems into smaller, clear steps, any language you learn will just be a new way of writing those steps. That's it for today's video on logic formulation. I hope this made programming concepts a lot more easier to understand. If you found this helpful, give the video a thumbs up, subscribe to more uh, beginner-friendly tutorials, and drop a comment below if you want me to explain other programming topics in a nutshell. Thank you for watching and happy coding!